Tonightly, we're talking synthetic division. We're going to ask the question, when can we use this? The answer is going to be whenever we're dividing by something that looks like x minus r. Yes, this is a way to divide without having to do all the long steps of long division, and it is amazing when you can use it. If you think about it, most of the times we're factoring as something that looks like x minus r, x minus something. By the way, what do you think that r stands for? The answer is root. Okay, I'm done. So if we want to do this division problem longly, it would take a little bit of time, not a long time, but there's a quick way. Let's just take the numerator and pull all of those coefficients off. 2, -10, 9, and -15. Now it is important when you do that these coefficients are in descending order. Otherwise this algorithm won't work. And this is very much an algorithm. It's a shortcut, but it's a useful one. Then we're going to create a pocket. And inside this pocket, think of that as half a box. I'm just like literally taking a box, drawing a box, and then subtly erasing the half of it and creating like a little pocket. So that's where it comes from. I'm going to create a pocket where I'm going to put the root in. So this x minus r, that root would be 3. It's going to be an opposite sign to what I want. So I'm going to literally divide by 3, but it's dividing by x minus 3. So next, we're going to draw sort of like a long bar, and I'm going to do an arrow and bring the 2 down. And then if you kind of think about this, this is sort of like a spreadsheet that's lined up. But I'm not going to put all that there. That's too crowded. I am going to put a little dot, dot, dot here. Like a vertical. I can do better than that. Okay, so here's the algorithm. Follow along. I carry the 2 down, and the 2 gets repeated. Then the algorithm is multiply, add, multiply, add. That's what I'm going to be doing here. So I'm going to multiply, add. 3 times 2 is 6. Add to -10 is -4. -4 times 3 is -12. -12 plus 9 is -3. -3 times 3 is -9. And then boom, -24. Wow, that was what the heck just happened. Okay, we're going to repeat all that here in just 1 second. So multiply. We're going to multiply the root by what we got, and to get 6, and I'm going to write it underneath the -10. Vertically, we add -4. Then I'm going to multiply these two, -12, and I'm going to add -3. Multiply, then add -24. What I want to do now is interpret my result, because what I just ended up with are the coefficients of my quotient. So because my quotient will be 1 degree less than what I started with an x cubed. This is a 2x squared minus 4x minus 3. And the -24 is the remainder, so that's minus 24 over my divisor, x minus 3. Number 2, we're going to write the coefficients out. 2, 9, 1, -12, and then I'm going to do -4. I'm doing -4 because it's an opposite sign. And if I wanted to make this x minus a number, it would be x minus -4, and that -4 would be the root, the r. I'm going to set everything up so it can look nice and pretty. Arrow for the 2, repeat the 2, dot, 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 dot. And now we're going to start. Multiply, add. Multiply, add. Multiply, and add. Remainder 0. What that means is this is a 2x squared plus x minus 3. How do I know it's an x squared? Again, it's 1 degree less than what I started with. Or a better way to do it is actually to work this way and say that this -3 is my constant term, then my quadratic term, and then my linear term. Or other way around, constant, linear, and then quadratic. So that also meant that what I essentially did is I just factored that thing. Much like we talked about yesterday, I factored this big long-ass polynomial, into some x plus 4 and this. So that's kind of neat. It's a way to factor without really factoring, and it's quicker than long division. Number 3, much like with before, I'm missing something. I'm missing that 0x. I should be able to identify that pretty quickly, but it's harder to identify here because ultimately what happens is that I don't have that x cubed, x squared, x problem visible. So I have to make a mental note. It's missing a 0x and then -49. create the pocket. And now we have another thing. I need to take this and rework it. That is not in the form x minus r. But if I rewrite the problem and I put it over 4 times x minus 7/4, now we're going to take this 4 and move it off to the side. Actually, I'm going to take the 4 and make that a 1/4 times. How can I do that? Well, I mean, those should be the same thing, right? When we multiply, we multiply across. But I guess what that means is that at the very end of whatever I get, I'm just going to divide it by 4. So what we're doing now with synthetic division is this piece. I'm just going to divide by x minus 7/4, which I can do if I stick a 7/4 inside this pocket. Create the vertical, create the dot, 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 and then multiply. Not as hard as it looks. This would be 14. Add to 16, multiply would be 28, add would be 28, multiply would be 49, and add to 0. So it's another remainder 0, 1. And what I get is this polynomial 8x squared plus 16x plus 28. But to be perfectly correct with this problem, I now have to multiply by the 1/4, or I like to think of it better as divide by 4. And so what I get when I divide by 4 is 2x squared plus 4x plus 7. And that's it. A quick check would realize that if I took 2x squared plus 4x plus 7 and I multiplied it by 4x minus 7, I don't have to check all the terms. I could. It's just take a little bit of time. But just do a quick check. Do the first ones give you 8x cubed, and do the last ones give you negative 49? If they do, then it probably matches the original, and it's decently well. Maybe not perfect, but probably going to be okay. I love how it also divides 4 cleanly. So let's move on. What can we do with this? We can answer the question, is x minus 5 a factor? If it is a factor of this, then I would expect something. You guys should probably anticipate what that something is when I divide. So let's use a darker color. 2, positive 5, negative 68, negative 35. Create the pocket, and inside the pocket I'm going to put a 5. So create the horizontal line, vertical, then carry the 2 down. 5 times 2 is 10, 15, 75, negative 7, positive 7, and positive 35, remainder 0. I don't have to go any further. I don't need to express my answer. The question is a yes or no question. And yes, and I can even go further because remainder equals 0. I can say, is 7 a root? If 7's a root, what that meant is x minus 7 is a factor. Because if it's a root, it solves this equal to 0 and x minus 7 factors. These are going to be talked about a lot tomorrow in terms of being interchangeable ideas. 7 being a root and x minus 7 being a factor are kind of saying the same thing. And you should know why that is, in the sense of know what the word factor means and know what the word root means. So I'm going to put 7 in the pocket because x minus 7 was the factor and 7 is the root. 5, negative 13, negative 146, negative 56. 7 times 5 is 35. Add, we get 22. Multiply, I get 7 times 22 is 140 plus 14, so 154. Then add 8, 56, 0. So again, we have yes, and for the same reason, because remainder is 0. If that remainder was any other thing than 0, then it would not be. Moving on, here's some great k questions. Negative 6, find k so that negative 6 is a root. Well, like we said for the previous two reasons, we're looking for a remainder equal to 0. Basically, I'm going to set up synthetic division like we have before. Take all of this, 1, positive 4, negative 5, and positive k. And I'm going to stick negative 6 in the pocket, and we're going to start to see what happens. I know what I want to end up with. We're going to make k so that that happens. Multiply, let's pocket this. Multiply, add, multiply, add, multiply. get negative 42. I want to add this to be 0, and there's my equation. K would have to be equal to whatever I would need to add to negative 42 to get to 0. K would have to be equal to 42. Moving on, I can even divide with things with i's. Isn't that fun? Let's bring the i's back. We're going to take the x minus I and stick it in the pocket and with the I, and I have coefficients of 1, 3, negative 2, and positive 3i. Positive 3i is the constant coefficient because it doesn't have an x in it. So it's acting like that here. Okay, put the little dot in and multiply. Add. 3 plus I is 3 plus I. Multiply. I times I is negative 1. I times 3i is 3i. So negative 1 plus 3i. Add negative 3 plus 3i. Multiply. I'm going to multiply the I by, oops, that did not look good. I'm going to multiply the I times this negative, or this 3i first. So I get negative 3, then minus 3i. And when you add, you get negative 3. So my result is going to be x squared, because of the quadratic term, plus 3 plus I x, there's my constant term, plus negative 3 plus 3i. Then I can say minus 3 over x minus I, or plus negative 3 over x minus I. This is a good way to express that. Again, quadratic term is the first one, then the linear, then the constant, then the remainder. Okay. Next one. Last one. Find the polynomial q of x and the constant r. This is a very complicated way of just saying something very simple. What I'm essentially doing is I'm saying polynomial divided by divisor is equal to quotient q of x plus remainder over divisor. Now the of x thing means that those might all be polynomials, but whoops, really what I'm saying is polynomial divided by divisor equals quotient plus remainder over divisor. And if you multiply both sides by divisor, what you get is the polynomial is equal to the quotient times the divisor plus the remainder. That over here is the same thing you always knew. The polynomial, or another word for polynomial here, is the dividend. Well, we won't put that there. But the polynomial equals the quotient times the divisor plus the remainder. That's basically how you do multiplication. That's what you did when you first learned multiplication. So this is just asking find the quotient and find the remainder. It's another way of saying divide. I know. Why didn't they just give you this 2x cubed plus 3x squared minus 4x plus 20i over x minus 2i? Why didn't they just tell you to do that? I know, because we like being complicated on you guys. So let's write this out. Positive 2i goes in the pocket because it's the opposite of the thing here. That's the root. Then 2, positive 3, negative 4, and positive 20i. So we're going to carry this down, and I'm going to put the little dot 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 and multiply. Add, multiply, slow down. 2i times 4i is negative 8 plus 6i. Then I'm going to add negative 12 plus 6i. Then I'm going to multiply. I get negative 12 minus 24i. And then add negative 12 minus 4i. That's my remainder, but it wants to find quotient and remainder. So what I would say very simply is q of x is equal to 2x squared plus 3 plus 4i times x plus negative 12 plus 6i. And my remainder, which I can just say r, is equal to negative 12 minus 4i. That's it.